Hey guys, Ms. McCorn here. I am recording this video on Unit 5. We're doing 5.4 through 5.9. This is all about kinetics, elementary reactions, and reaction mechanisms. Go ahead and pause the video here. That way you can write down some of these learning targets in your notebook. Make sure you write these in your own words. So the first thing we're going to talk about are reactions. So it's really important to know that reactions, in order for them to occur, they actually have to have enough energy to occur, and the collision, when they do collide, has to be in the correct orientation. The angle has to be correct. So just because two different molecules actually run into each other, it doesn't mean that just because they collide that they're going to react. They have to collide at the proper orientation, and they have to collide with enough energy. So you can have several different kinds. You can have one molecule. Generally, that's going to be radioactive decay, where one molecule splits down into two molecules or more. That's unimolecular. You can have two molecules where A plus A, the same molecule, hits each other to get products. Or you have an A plus B, where you have two different things colliding at the right collision with enough energy to get products. Very rarely you'll have three molecules. They have to hit each other at the same time with enough energy to have a reaction in order for those to have products. One thing I do want to point out, you'll notice here I wrote that with two molecules you're going to have second order reactions at that point. So when we have reactions, we know that with stoichiometry it's going to be predictable. We know that with 2 moles of nitrous monoxide we're going to get 2 moles of nitrogen dioxide. And with the rate law, though, we've already talked about that, it has to be measured experimentally. We're not going to be able to predict the rate law from just looking at this. We have to be able to measure that experimentally. What we haven't talked about yet is that most reactions are actually multi-step. We're not going to have reactions that occur in just one step, but we have what we call elementary steps. So it may take 1 step, 2 steps, 3 steps. Usually it's not just 1 step. It's going to happen in several different steps, not always 3, but those different steps are going to equal up to a balanced equation, and what we call that is a reaction mechanism. Okay, so all the elementary steps together are again called the reaction mechanism. So we usually have a pretty good idea of what the reaction mechanism is. It can be postulated. Once that is known, we can actually find the rate law. Remember, we can find that experimentally, but we can look at the rate law using what we know for each of those elementary steps, and we can actually predict what those rate laws are for each of those elementary reactions. Here is an awesome example. Okay, here's a reaction. So anytime you see a reaction like this on an exam, they are actually going to give you the reaction mechanism, which, remember, those are elementary steps. That's called the reaction mechanism. They will give that to you, and then they'll ask you a question about it in order to solve. So here we have step 1 and step 2. So we have it breaking down, adding up 2 of our NO2s. They're going to collide first, and then we'll have NO3 and NO. And then our NO3 is going to collide with our CO in order to get NO2 and CO2. So what we do have is what we call intermediates. Intermediates are when we have things that actually are not in the final reaction. So what we look at is anything that's in the final reaction we're going to cross out here. So CO is in our reaction as a reactant, and NO2. Those are in our first reaction, right? And then over here we have CO2 and NO. So here we have these are intermediates. So what we see here is crossing out all the stuff that's in the final reaction, and then what we have left over, those are our intermediates. Now for the super fun part, we want to be able to determine the rate law. So, of course, what I said before was we're going to have to find what the overall reaction is. We're going to have to look at those elementary steps. So, same reaction again. Here are our elementary steps. So what we do is when we find our rates, what we're looking at is, remember, it's going to be K which is our rate constant, times the concentration. Okay, and we're going to, of course, use our coefficient here. All right, and right here what we're doing is we're just looking at the disappearance of the reactant. For step 2, we're going to do the same thing. So the K, and we're going to put that 2 there just to show that we're doing the 2. I'll put a 1 there to make sure that's well known. So we have NO3 and then CO. Okay, so those would be our rate laws. So for any elementary step, okay, we will always have this. The K is going to be that you have the rate constant, and then you'll have the A and the B. It's always going to be those reactions. So, interestingly, step 1 has the same rate as the overall reaction. I'm going to show you that now. So, to explain to you why I said that the overall reaction had the same rate as that first step in our elementary steps, I'm going to use a little analogy. So we know that when we are on the interstate, you don't drive, that's okay. When you're on the interstate, you have generally the speed limit of either 70 or 75, depending on where you're driving. So, sticky notes are getting stuck. So when you're driving along, you know, you can just drive right on through, correct? So that's all my sticky notes are sticking. So I have all my little cars, and they're going to drive right through because they're going 75 miles an hour. Now, if you have not driven to Baton Rouge in a while, or ridden in a car with, you know, somebody, friend, parent, you'll not realize this, but I'm sure most of you have. And there's a whole lot of construction going on around between Prairieville and Highland, a lot. So when they have this men at work sign, you have to go, it's like 50 miles an hour. So the speed limit is like really, really slow. Not only is the speed limit like really slow, then they say the traffic fines are doubled and it's really annoying. So what happens is this slows everybody down. So everybody got to slow. And once you get through here, you speed back up. Okay? So all the cars are going to kind of get slowed down right here. But then over here, they're going to speed right back up. So we're going to slow down here and speed back up. Okay? So what we are calling this right here, this slow step, this is our slow step where everything slows down. No matter what it is, it's slowing down. This is called a rate limiting step. Okay, this is what is going to actually limit the rate of our reaction. So again, when we are given problems like this on the AP exam, this is going to be told. We are going to be told which one is the slow step and which one is the fast step. Now, what you may have to do is determine what the rate law of that step is, and then once you've determined that rate law, then you'll say this particular one is the rate of the overall reaction. You'll know that because you'll know that the rate limiting step is the one that is going to determine the overall rate of the reaction. So, if we look back at our previous, right here, this was the slow step. Of course, they would give you this if this is a question on a test or exam. This is the rate limiting step, which is why this is our overall reaction rate law. I'm running a little bit low on time. I've got a minute left. I know I won't be able to get these examples done, but I am going to post a quick example video just to show you 2 examples of the rate limiting steps and how you can find the overall rate when you were given those elementary steps and you're able to do the rate limiting step. So stay tuned and make sure you watch the next video. Both of these will be for your homework grade.